Let's solve few problems based on derivative on inverse trigonometric function. Look at the first one. Y is equal to tan inverse of 3x minus x cube divided by 1 minus 3x square. Now, in the previous video, we just discussed different types of formula, isn't it? Now, in this, see the first one. Now, what we'll do, we'll substitute x as some particular value. That means here, we'll take x is equal to tan theta. Now they have given you a value for x also. X is between minus 1 by root 3 to 1 by root 3. Yes, so we are abiding by that particular rules itself. That means here theta is between minus 30 and plus 30. That's what we mean by this. Okay. Now x is equal to tan theta. Substitute. You will get y is equal to tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Correct? So what do we have? Y is equal to tan inverse of tan 3 theta, isn't it? Now tan inverse of tan 3 theta. So this becomes y is equal to 3 theta. Correct? So see, x is equal to tan theta. So what is theta? Tan inverse of x, isn't it? That means what I'm looking at is I'm looking at this part. X is tan theta. So theta will be equal to tan inverse of x, isn't it? So you substitute this theta as tan inverse x. That means you get y is equal to 3 tan inverse x. This is just the value of y. This is not y dash or dy by dx, whatever. So we need to calculate dy by dx. Differentiate. Don't you think tan inverse x is 1 by 1 plus x square? Remember the table. So y is equal to 3 tan inverse x. So y dash, we'll just calculate it. So I'll do one thing. I'll write it right here itself. So you'll get y dash is equal to 3 divided by 1 plus x square. So at the end, this is going to be the answer. Because we substituted x as tan theta, the entire problem, whatever you have, it just got reduced to just 3 tan inverse x. If you remember the formula in inverse trigonometric function, fantastic. If you don't, just apply this one step, you'll get the answer. This is the answer for the first one. Let's solve the next one. See the second one. Sine inverse of 1 minus x square by 1 plus x square. Guys, if you think about it, for cosine you have this 1 minus tan square x by 1 plus tan square, but not for sine, isn't it? So now what do? We have to write this in terms of sine. Otherwise, sine inverse will not get cancelled, isn't it? So what do? We take x as tan theta. Okay, just take it and we'll see how it goes. So first what we'll do, let x is equal to tan theta. So we have theta is equal to tan inverse x. This is common, right? So since x is equal to tan theta, we'll get y is equal to sine inverse of 1 minus tan square theta by 1 plus tan square theta. Well and good. Y is equal to sine inverse of cos 2 theta. Correct? Isn't it? Now, if you remember the complementary angles, cos theta is sine of pi by 2 minus theta, isn't it? So we can also write the same thing, sine inverse of cos 2 theta. So we can write this as, so here I'm going to write it. So we can write this as y is equal to sine inverse of sine of pi by 2 minus 2 theta. Because it is cos 2 theta. If it was just cos theta, you could have written pi by 2 minus theta. So this here it's going to be pi by 2 minus 2 theta. Now what can you write this? Y is equal to pi by 2 minus 2 times theta. What is theta? Theta, we know theta is tan inverse of x. Substitute. So this is going to give me y is equal to pi by 2 minus 2 tan inverse of x. Now do y dash. Did you understand how to reduce the problem? Whenever you are trying to reduce the problem, first identify which trigonometric function to substitute. Okay, this is the first step. Second step is, once you substitute the trigonometric function, how do you reduce it? Okay. Third step, or you can say the third point in solving these. If you could not reduce it, can you convert one trigonometric into another trigonometric function, like what we have done in this particular problem? Then the last step is finding the derivative. Understood? So now if you find the derivative, so we are going to have y dash is equal to, this is anyway 0, pi by 2 minus 2 into 1 by 1 plus x square. Or we can write this as minus 2 by 1 plus x square. So this is going to be the final answer. Minus 2 by 1 plus x square. This is going to give me the derivative of the second problem what we have. Now we'll go for solve the third one, which is very, very similar to the second one. So third one is going to be easy. Let's do the third one. See the third one. Now what you have is cos inverse of 2x by 1 plus x square. Again, if you remember, sine 2x was 2 tan x by 1 plus tan square x, isn't it? So when you take cos inverse of this particular function, so what do you do? Take x is equal to tan theta. So theta is equal to tan inverse of x, isn't it? If you substitute, y is equal to cos inverse 2 tan theta by 1 plus tan square theta, correct? Now, if you remember the formula, cos inverse of sine 2 theta, correct? Again, what can you do here? You can write this as cos inverse of sine 2 theta, which you can write this as cos of pi by 2 minus 2 theta. Alright. So you'll get this as pi by 2 minus 2 theta is the value of y. Substitute the value of substitute the value of theta. Y is equal to pi by 2 minus 2 tan inverse of x. So once you substitute and once you differentiate now, 0 minus 2 into 1 by 1 plus x square, or the final answer will be y dash minus 2 by 1 plus x square. This is going to be the answer. Now you might be thinking, for the previous one and this one, we are getting the same answer, minus 2 by 1 plus x square, isn't it? So are these two problems one and the same? Now the result is going to be different, as in the geometrical meaning is going to be different, right? I'll just give you a brief explanation because I'm not going to go into detail of it. See, the geometrical interpretation of the derivative is going to be slope of a line at that particular point. Okay, this is the geometrical interpretation. Now, two functions, the second one and the third one, both of them are giving me the same dy by dx or y dash, that is minus 2 by 1 plus x square. Correct? That means there is one common point for these two functions where the slope of a line is going to be the same. Alright, the slope of the line is going to be the same. Now, this is the reason why we have that the derivative are equal, but the function is not equal. Obviously, the functions can change. But the slope of a line, especially the tangent, slope of the tangent at that particular point is the same. That is why the derivative of the function is the same. Understood? This is one way of explaining. There is another way of explanation for these two. Now look at the range of the second one and the third one. Range is different. See, for the previous one, I could have done pi by 2 plus 2 theta because sine is still positive in the second quadrant. Is it not? But if you look at the range, it is from 0 to 1. 0 to 1 comes in the first quadrant. So pi by 2 minus 2 theta is the correct one, not pi by 2 plus 2 theta. Understood? Likewise, in this question also, it is from minus 1 to 1. Isn't it? When it is from minus 1 to 1, so whatever the value we are taking, it is going to be in that particular range itself. Understood? That's why the range, what they're giving, is quite important. And the answer for this is going to be this. Well and good. Now let's do the fourth one. See the fourth one? Now in this, take x value as sine theta. Or you can take it as cos theta also, because both of them will work. Understood? Both of them will work. Now if you take x as sine theta, then you'll get y is equal to sine inverse of 2 sine theta to root of 1 minus sine square theta. Sine inverse of 2 sine theta into cos theta. Isn't it? Which is nothing but sine inverse of sine 2 theta. So what do we get? We get y is equal to 2 theta. So what is theta, guys? Theta is sine inverse of x. So you get y is equal to 2 sine inverse x. Differentiate. You'll get y dash is 2 divided by root of 1 minus x square. Correct? So this is going to be the final answer. Now some of you would have thought, why not cos theta? You can, no problem. Okay, you can use it. If you use that, you'll get minus 2 by 1 plus x square. Sorry, minus 2 by root of 1 minus x square. That is going to be the answer. Fine, there is no issue with that. Depending on what you're substituting, you guys will get the answer. Well and good, not an issue. Fine, this is the answer for the fourth one. Now let's do the fifth one. See the fifth one. See here, secant inverse 1 by 2x square minus 1. Guys, at the end, basically what you need to get secant theta somewhere within the bracket, correct? Like basically you have to get secant inverse of secant of something, correct? So you have 1 by 2x square minus 1. So when you have 1 divided by something, so the 2x square minus 1 should give me in terms of cos, correct? Now start thinking of the multiple angles, what you can substitute. The best nomination what you can get for this one is going to be cos theta, because 2 cos square theta minus 1 is cos 2 theta, isn't it? So what you get, take x is equal to cos theta, right? So theta is equal to cos inverse of x. Next, what do? You're going to substitute. So you'll get secant inverse of, so y is equal to 1 divided by 2 cos square theta minus 1, right? Which is y is equal to secant inverse of 1 by cos 2 theta. What is 1 by cos 2 theta? Secant 2 theta, isn't it? So you'll get y is equal to secant inverse of secant 2 theta. Right? Once you have this one, what do you get? Y is equal to 2 theta. Or in other words, you can write y is equal to 2 cos inverse x. Correct? Differentiate, you'll get y is equal to minus 2 divided by root of 1 minus x square. This is going to be the formula, or not formula, more like the answer for this particular question. Minus 2 by root 1 minus x square. Understood? So this is the answer for the fifth one. Now let's do the last one, sixth one. Now for the sixth one, I think it's pretty obvious what you need to substitute, isn't it? So take x as tan theta. So theta is going to be tan inverse of x. Substitute. That means you'll have y is equal to sine inverse 2 tan theta by 1 plus tan square theta. Correct? Y is equal to sine inverse of sine 2 theta. Correct? So since you have sine inverse of sine 2 theta, y is equal to 2 theta. Take theta as tan inverse x. This will be 2 tan inverse x. So y dash, substitute. So y dash will be 2 into 1 by 1 plus x square. Or finally you can write y dash is 2 by 1 plus x square. So this is going to be the answer for the last one. Clear? Now, whatever problems we have solved so far, everywhere we have substituted, correct? X is equal to some trigonometric function, or y is equal to some, not y, x is equal to some trigonometric function. Remember, in all the cases, it's not about directly differentiating it. Instead, you substitute a trigonometric function, reduce the question, then at the last step, that means the reduced question, that's where you're substituting, that's where you're differentiating, isn't it? So all inverse trigonometric functions, they follow the same logic. First, you substitute the trigonometric function, reduce the question, then you differentiate and get the correct answer. Fine. So these are certain questions. Now from the next video onwards, we'll look into different topic under differentiation.